Okay, so now 2B, it says, describe the energy stores of the ball at the top of the release. Right, so at the top of the release, compared to its energy stores at the top of its bounce. Okay. Well, okay, so I did actually sort of describe that anyway in the previous video, but essentially because it's nearly at the same point, we would say that the energy stores are basically gravitational potential energy, and it's nearly the same amount. Okay, it's nearly the same amount because it's at the same height, or nearly at the same height, and so not much thermal energy would have been produced. That's all you can say really for 2B, which is why it's only 1 mark. Then we got C. Describe how you would use the test in A to see which of the trampolines is the bounciest. Well, we want, if the trampoline is particularly bouncy, then not much. Then if you drop something and it goes back up again, it's going to go up to pretty much the same height. Not, it will always lose some height because you can't have zero friction, but the higher it goes, the better the trampoline. And in fact, you can actually work out the efficiency of the trampoline, because you would say that the starting height. I need to zoom in again. Well, that's what it started. Let's say that could be. I don't know. Let's imagine that was 1 meter, and then the end height, like after it's done one bounce, the end height might be 70 centimeters. Now, if it was that, then the efficiency would be 70%, right? But because it's 70% of the 1 meter. But if it was harder to work out that, if the numbers are a bit more tricky, then the formula is just simply going to be the end height divided by the starting height, and that would give you the efficiency. So the efficiency, and you'll be learning about efficiency fairly soon, is going to be equal to that. And if you want it into percentage, you just times it by 100%. Okay.